Okay, guys, let's look at the second. Okay, guys, let's look at the second student task statement. A train is traveling at a constant speed and goes 7 and 5/10 kilometers in 6 minutes. At that rate, number one, how far does a train go in 1 minute? How far does a train go in 100 minutes? Okay? So, I'm going to show you guys two different methods to solve this, okay? And I want you guys to pick the method that you feel the most confident to use in the future, all right? So, let's look at this problem. Is there anything that I need to annotate or pull from this problem to help me solve these questions? If you guess 7 and 5/5 kilometers in 6 minutes, you are absolutely correct. All right. The first method I'm going to show you guys is in ratio form. So I'm going to call this method the ratio method. What I'm going to do is take this sentence, I'll take the fragment of the sentence and turn it into a ratio. I'm going to do 7.5 or 7 and 5/10 kilometers. I apologize. I think I was saying 5/5 earlier, but it's 5/10 kilometers. To 6 minutes. Now, in the past, I used to tell my students, look at question 1. It's asking us, how far does the train go in 1 minute? This is imperative, okay? This is imperative. So in the new ratio, I want you to put 1 minute because that's what it's wanting us to know. So if you're wondering, hey, where did you get 1 from? I got it from the question right here, okay? So then I asked my students, which side is it telling us that it wants it to go to 1? Does minutes need to go to 1? Or does kilometers need to go to 1? Obviously, minutes need to go to 1. So divided by 6 on both sides. I'm going to divide both sides by 6. When I do that, 6 divided by 6 is equivalent to 1 minute. Now I have some math work to do on the side. I'm going to put 6 outside the house, 7 and 5/10 inside the house. What you could do is put that decimal, line that decimal up on top. And ask yourself, how many times can 6 go into 7? 6 could go into 7 one time without going over. 7 minus 6 is 1. And then you're going to drop that 5. How many times can 6 go into 15 without going over? If you guess twice, you are absolutely correct. Now the 3 is remaining, but I don't want to turn it into a fraction because we already have a decimal. It's already in decimal form. So what I want to do is add a 0 and drop it down. How many times can 6 go into 30 without going over? If you guess 6 could go into 35 times, you are absolutely correct. So this number I just found is the kilometers. So in 1 and 2,500 kilometers. So 1 and 2,500 kilometers. So the train could travel 1 and 2,500 kilometers in 1 minute. So that is the ratio method. I also want to show you guys the tape diagram method, which you guys will be more familiar with if you use Eureka last year. I'm going to use the tape diagram method. All right, so the tape diagram method. Okay, so what I want to do is I want to create this tape diagram, okay? But the tape diagram is going to represent the time. So it's going to represent 6 minutes. So how many pieces do I need to partition this tape diagram into? If this tape diagram is representing the total amount of minutes, how many pieces do I need to partition it into? If you guess 6 pieces, you are absolutely correct. So what I tell my students is draw 5 lines to make 6 pieces. So 1, 2, 3, 4, 5. And I'm just going to draw an extra one for 6. Okay. So this whole thing represents minutes, and the train traveled 7.5 kilometers in 6 minutes. Okay. So, and I'm going to put that each box represents 1 minute so you guys understand. So you need to figure out, well, if 6 pieces represents 7.5 kilometers, then how much does 1 piece represent? Now, what you can do is you can do the same thing. I would divide 6 divided by 7.5 or 7.5, and we would get the same number, which is 1 and 25/100. So what you do is put it in each box. And keep in mind, I got that 1 and 25/100 by doing the same method. We see it's a different way to approach it, but at the end of the be all, you still have to do some long division to find out, well, how much can 6 go into 7.5? Okay. So, the train could travel for number 1. How far can the train go in 1 minute? 1. 1 and 25/100. Okay. So for question 2, kilometers, I apologize. Please don't forget your unit. All right. So for question 2, which I'm going to be annotating in green. Now I found the unit rate, okay? I found the unit rate. The train can travel 1 and 25/100 kilometers. The train could travel 1 and 25 kilometers in 1 minute. So how many can it go in 100 minutes? Now, if you still want to use this ratio method, you can. So if I have, what can I multiply 1 by to get to 100? If you guess I can multiply 100 by 100, 1 times 100 to get to 100, that is absolutely correct. So you can multiply both sides by 100, you'll get 100. Now, if you're familiar with multiplying 100 times any decimal value, you'll know that the decimal will slide back twice, which will give me 125 kilometers. If not, I have no issues with showing you guys how to multiply by a decimal. So 1 and 25/100 times 100. This will be 0. They all will equal 0. Move it up once. All of it will equal 0. And then it'll be 5. Okay. And then I will add that together. And then you ask yourself, well, how many numbers behind the decimal? We have 2 numbers behind the decimal, so therefore 2 numbers need to be behind the decimal in our answer. And our answer would be, for number 2, 125 kilometers. All right, guys. So keep in mind, I want you to pick the method that you feel the most confident in, okay? Now, if you have any questions, please feel free to visit your manager's Google Meet session, and I'll see you guys in the next question.